Hello everybody and welcome back. Today I get to review something that I wanted for a long time. It's the MDP XP Digital Power Supply from Miniware, and this is one of those things that I really wanted to review for a long time and wanted to buy it for a long time, but I kept pushing it aside because, well, I had power supplies. They weren't great. In fact, they were really old, but they just did the job. So when Banggood contacted me and asked me if I wanted to review this, I jumped at it right away. And yeah, first of all, let's have a look at what is in the box. This power supply is actually two parts. So first, we have a monitor device, which is the screen, and we have the power supply itself. So this works in a way that you got the power supply and you have the screen, but you can attach more than one power supply to the screen, which makes it pretty unique. And everything is nice and small. In fact, it looks really, really nice. It is incredibly beautiful. This here's the display device. It's aluminium. It's a nice black design. Just a few buttons to the bottom. Turn dials to the right. Very simple, very sleek. These do not have a push function. They're just up and down adjusters. Very, very simple and very, very effective. And the power supply is just the same. Same size, basically almost the same form factor. Also, a very, very simple design. 3 push buttons, 1 turn dial. And the beauty of this is, let's remove this here. The beauty of this is you can stack them and they'll just attach one another via a magnet and they'll stay put in here. You can't turn them upside down, they will come apart. But it holds together really well. And that's it. This is so simple. This is so small. It is just beautiful. And it has a few more features, like you can power it through a USB-C. That being said, mine doesn't play well with power supplies that have the USB power on demand. So it won't work with every power supply, but I'll get back to that. And there's a standard power jack where you can attach any power supply up to 30 volts. There is a port here for programming it and for passing on power to the display, because the display itself does not have a battery or a power supply. But it can be powered through mini USB, and there is a small cable included with the set that allows you to connect the power supply to the display. Like so. And that's it. Now you can put this down on your desk. You can fold the display up, which is very nice, very simple, with a really sleek design. And this power supply comes with pretty amazing numbers. It is super fast in regulating it. It has, apparently, they claim, a transient response to a current change of less than 4 microseconds. That means they have a really fast CPU running this thing. They have ripple and noise values. Ripple is 250 millivolts RMS, which is quite good, and noise is supposed to be 3 millivolts peak to peak. Now, I don't think that I have measuring equipment where I could actually measure down to that level and prove them right. I may try to prove them wrong, but even for the size and for the mobility, I'm actually willing to go for quite a lot less than that. But let's just turn it on. Now, to turn this on, you could either use a USB-C cable and just connect it to a power bank or something like that, which is what I'm going to do. I'm just going to use my trusty old power bank and connect this and turn it on. It comes alive right away. So it has a very short startup period. It's almost instantaneously on. The display is really simple and clean. You can see the set voltage. You can set your maximum current, and you can see what the input voltage is and what the input current is. And as you can see right now, I am only using a 5-volt supply, but I've got a 12-volt output. So even more amazingly, this thing has a boost converter, so it actually steps up the voltage. You can power this from a notebook or a PC computer, and you can get voltages that are much higher than the supply voltage. This is really, really cool. This is amazing, and it makes this even more mobile. You can really take this thing along and just operate it off your mobile device or just off a power bank. So I am really, really happy with that. The display here in the front also displays the voltage and the current settings, and of course you can use the power supply to generate a constant current. So it has CV, constant voltage, or constant current modes. The two devices, once you separate them, will of course continue to work, and you can actually separate them by more than 3 meters. So you can have this on one bench and this one on another, and you can power them separately. They don't care. They talk to each other through Wi-Fi or some other sort of 2.4 gigahertz communication, and it is really, really simple. Now let's get this hooked up to a meter, and let's get some of the values about the voltages, and then let's try to measure some currents. So I did get my setup for testing this already, and I've set the power supply to 2 volts, and let's see what we get here. So right here we can measure 2.01 volts. We can see on the output we have 2.002 volts. This is the fluctuation we're having in the last digit here, and it looks pretty much up to par. This device here can measure irregularities like ripple and noise, but it is basically saying there is none. I had a few values of noise right around 10 millivolt, but they would come and go away. So yeah, this is pretty good. I do have 50 ohms of load on this line, so there is a little bit of current flowing here, just to make sure that we do get a good saturation and that the power supply is actually doing something. Let's step it up a bit. Let's go up to 3 volts. With 3 volts we are reading 3.001 volts. There we go. This takes a few seconds to do its measurement. There is no noise on here. The values here are a bit higher, but this is a pretty old device, but it still does pretty good at measuring problems with the voltage. Okay, let's go up further. 4 volts. At 4 volts we're seeing 4.01 volts here, 4.1 volts over here. We do have a slight bit of noise. Apparently 18 millivolts peak to peak, but it seems to have calmed down now. Let's have another look. Yeah, it's back down to 0. So let's go up to 5 volts. At 5 volts we can see we've got 100 milliamps of current going through here, which is 0.5 watts. It actually says all of this here. And we can see a little bit of ripple on this display here, but it's not really measuring anywhere. Well, let's continue upwards. 6 volts. At 6 volts we have 6.01 volts on the device here. We have something around that. It did get a little bit of noise while switching over, but oh, we seem to be having a little bit of noise. Oh yeah, right now the output voltage is higher than the input voltage, and since we're still running off the USB power supply, that might be generating a bit of noise because it has to go through the boost converter. Let's go to 7 volts. At 7 volts we have 7.01. I think I see a pattern here. Yeah, right now it's 7.00. Yeah. Same here. No noise, no nothing. Let's go up to 8 volts. At 8 volts we have 8.02. No noise, and we're just a little bit above that on this device here. So it is actually really true to the values that they claim, and it is really spot on. So I'm going to go to 12 volts just for a second. At 12 volts we have 12.04. Right here we have 12.3 with a little bit of noise, and my my resistors are getting hot now, so I'm going to stop at this point. But we are really spot on for all voltages. I'm going to remove the resistors right now, and we're going to try and go higher than this, but without a load. I did remove the load. I went back to the 12 volts. We can see 12.04 volts on our voltmeter. We do have very little noise that we can see. Well, there's a bit. And let's go higher. Let's go to 16 volts. At 16 volts, the multimeter says 16.05. We need to increase the range here. Give it some time to do a measurement, and we're pretty much spot on. No noise, no issues. And we continue on upwards up to 21 volts. This is where it actually stops, is it? Yeah. So we're getting 21 volts of power power of voltage. We're measuring 21.06 volts, and well, now we do have a little bit of noise on here, but it is almost nothing. Yeah, and it's gone again. So yeah, in regards to voltages, with a bit of load, with no load, it's basically spot on. Yeah, let's continue. So the second test that I want to do is I've attached a 50 ohm resistor. I'm going to set the voltage at 10 volts, and I'm going to set the current limiter at 200 milliamps, which should cause it to go into constant current mode. And what I want to see is if we get any jitter in the voltage, or if it just holds that current pretty solid. So here it goes, and we've got 10.3 volts set. We have 200 milliamps, and it's a 47 ohm resistor, so we're getting 9.04 volts on the multimeter. We're not seeing any noise, and the power supply claims that it is supplying 9.032 volts, so we're really close with the values. And once again, there's nothing to be upset about here. So let's try to lower that value. At 100 milliamps, we have 4.52 volts. Same thing here, 4.51 volts reported by the power supply. And there is a small amount of noise on the line, but it just goes on and off, which is really cool. Let's see if we can get better reading. So just if you're wondering, this device is really old. It's at least 25 years old, but it's one of those Swiss Army knife things. It just does its job. So I'm seeing 18 millivolts of noise on here. Could be it's a bit high, but maybe that's true. I can also see some jitter on the display here. Could also be the resistor getting warm now. I can already smell it, so so let's up the voltage. The menu is really simple. It's so nice to use. Let's set our limiter at 20 volts and do some quick tests. So we're going back to 200 milliamps, we're at 9 volts. We're going to 300 milliamps, we are at 13 volts. Holding absolutely steady, there's nothing moving here, which is really nice. We're getting a smell of resistor, and we're going to stop this pretty soon, but just for a second let's try to reach 400 milliamps. Here we go, and it turned off. I had that bug a couple of times. Well, it must have been my power supply. I'll plug it back in. Yeah, and it's back. It doesn't forget anything that you put in here. All of the values stay in here. So 300 milliamps probably worked, and we couldn't get any higher than that. Let's see if we can go through the settings. and go to 320, 310. Yeah, working really nice. Really, really nice. But I'm going to turn it back off now. So there's nothing to complain about here. It does what it's supposed to do. It holds its voltages pretty stable. It holds the currents pretty stable. It actually stops dead on the currents. So it's a very nice little power supply. Really cool. Now, one thing about the power supply that is worth mentioning is it does not provide power separation. So the negative terminal or the ground terminal is connected to the supply ground. So it does not provide any separation. You should know that if you try to have different voltages, and you can't use them. You can't use two of these supplies to add them. You could only do that if you have completely separate and isolated supplies, but you can't daisy chain these. Also, it's pretty important to know it won't turn on itself, and it won't just turn off itself. It does have a run and a stop button, which actually turns it on. When it turns on, the ports light up, so it's really easy to see if this thing is running or not. And the rest of the settings are really, really simple. The menu just lets you set the maximum input current, and the set on the device lets you scroll through the voltage or the maximum current. So you can use both of these devices. You could even use the power supply just by itself without the display, which is also really nice. Also, there is one more thing that is really important to mention about this device. It's the USB-C input on the back here. First of all, it does not support power delivery over USB-C, so it does not work with a lot of USB-C power supplies, which is actually regrettable, because they would be able to supply power that this thing needs, and it would be able to select the right voltage too. But I couldn't get it to work with any of my dedicated USB-C chargers for notebooks. The only thing that it would work with is a USB-C power bank. The other thing about the USB-C port on the back here is it is also used for the DFU upgrade of the firmware in the power supply. Now, up to some time ago, there used to be a cable included with this device where you could hook this up to a USB 2 port, and it was an adapter from USB-A to 2.5 millimeters headphone jack. These are no longer included. I went through quite a lot of effort to find this out, because I was just assuming that it was missing, because the first cable that I used to try a DFU upgrade didn't work. And so did the second cable I used, and through my whole stash of USB-C cables that I was able to attach to this and to my PC, and get them talking, I ended up using an adapter, USB-C to USB Type A or USB 3.1, and a really cheap USB-C cable. In fact, this is probably the cheapest that I have, and this one worked, whereas all the others that I had that were a lot thicker, longer, and more expensive, and they already included the adapter part, like this one here. They didn't work. They didn't work at all. So if you get yours and you're trying to do an update through the USB-C port and it doesn't work for you, just try another cable. I had a very long discussion with Banggood, and they told me these 2.5 millimeter jacks, 2.5 millimeter jack to USB-A adapters are no longer included or needed. And after I couldn't get it to work, I actually contacted Miniware, and they were very nice, and they told me, well, you might want to try another cable. And they were right. They were pretty right about that. So for me, everything works on this device. It is really nice. The only thing that I would love to see was power delivery support for the input on the back here, because that is missing. Also, I was not able to find anything really wrong with it. It just works. It holds the values that you tell it to hold. It has decent current. It also has pretty stable voltage. They claim really great values for the output, and while I was not able to confirm that these are right, I wasn't able to prove them wrong either, so I suppose this is pretty good. And the last thing that I really like about it is that it has a step-up circuit, and you can use that to attach a 5-volt power supply and still get up to 20 volts of output. That is just amazing. And so I really like this device. This is a really cool thing. I also like that it can be split into 2, and that you can use the display for up to 6 power supply devices and just have it display all the data. I've never had something like this before. Most of my power supplies are really old, or if I need them, I just build them on demand, and I use simple buck converters for step down, or I use boost converters for step up, and I usually make it fit the purpose. But something in this size and with this amount of features, this is just great. I just love it, and I am really, really grateful to Banggood that I could get one for a review, and I just like the device a lot. So this is my review of the Miniware mini power supply, and it's a really nice device, and it's sturdy, it does a great job, and it looks great. So that's it for now. Thank you very much for watching, and bye bye.